a lot of experimenting, failing, and at the same time, being successful with it. So we just look a little into some details about how your system could actually think better. So what we covered today, we look at the journey so far. Like I just mentioned, we're going to take a look at evolution, some of these architectures without total deep dive into any of them, but briefly just talk about them, since some of us are actually familiar with these architectures too as well. What microagents are, and some problems with traditional microservices. I won't say not entirely a problem, but some of those drawbacks that I feel like we can improve if we infuse a little bit of context analysis, understanding that AI brings to your microservices to it. That's where we talk about the adding intelligence to your microservices, do a bit of comparison with the architecture, right? What will change, what could change. You're not going to entirely throw away your microservices, really. I think the idea is to find a way to supercharge them and ensure that they still perform optimally according to your business rules. And then just a bit of live demo. To be honest, the live demo is just based on mock services, but I will try to explain the concept behind it, what you would need to architecture a system like that properly. And then, we can share ideas, questions, and then response in between. That's a question, Q&A. All right, who am I? My name is Oluyemi. I'm a software engineer for a company called CV Library Group. More like a month into the company now. So we build product to ensure that candidates can get lovely employments, get employers that matches your mission and all that. And employers too as well can actually look for ideal candidates that can actually build products for them. Fitness enthusiasts, I love football. This is not a good time to be a Man U fan, but I'm actually a loyal fan. And I love music. And just a bit about evolution. I don't know why container came up first, but so the idea is we have monolith application. We all started with that. I think that is where most systems started from. You have this big, gigantic applications with a couple of functions here and there that actually carried out some of your business rules. Single database. And over time, this started evolving as business and product and software engineers get complex. Right now, I feel like most companies, even when they don't need a microservice architecture, are seriously adopting it. To some extent, if you starting a new company, you're building a startup, you don't just jump on microservices, to be honest. So that is still saying, emphasizing on the fact that monolith is still relevant, even though there is popularity of microservices. But the evolution looks like this. We started from microservices, one big ball of everything, monoliths to microservices, split some of this into different responsibilities. So you could have a service for payments, a service for just notification systems only. And it does that only, even though it might be templated, where you just need to pass a couple of variables to it. But it works. And the system becomes distributed systems. We need to manage them, orchestrate them properly, make sure they're actually communicating, request and response, or different design patterns or communication patterns that you might want to employ. And better deployment, you have containers and Kubernetes. There's a lot of nuance to this part because there are so many tools now in the community. There are tools that actually even help you coordinate your Kubernetes cluster, different pods, and it's just getting complex, every time, but it works. And now this is where I think we are, Microagent, where we start thinking about what can we do to ensure that our microservices can actually still, am I blocking you? Okay? All right, cool. That our microservices can still reason a little bit. What I mean by that is most times when we build systems, of course, you have your product owners. There's a business that needs to be solved. There are always conditions, if else. And now, if those conditions are not met, your customers are not going to get the response. So you're expecting a specific payload request to be sent. And after that, carry out some of those rules, return the response back to them. Happy days. Your customers are happy. You get paid as well. But we've seen this over time, the need to actually go back and revise some of this business rule, right? Product owners will have to come up, okay, this is what customers are talking about. Can we adjust that? And then you'll have to go back to the code, make some changes, readjust a little bit. And if you're building a SaaS product, sometimes you don't want to go back and do this all the time because you might have customers who your tool works for them. But you might have some who want to also make specific adjustment to it. So except you're building different tenants for different customers, you want something that to some extent can actually understand their context properly and then be able to suggest directions and solutions for them. So looking at this, let's break it down. What's a microagent? Really, nothing changes, to be honest, much. You see, you have your existing business logic, but it's just you have your microservices with some sort of brain to think differently, right? One key takeaway there, which is the funny one, is your services with emotional intelligence has gone to therapy, learn a little bit of how to think, how to reason, and then come back to start acting based on context. For example, if you build in a payment system, some of us have been there. You try to make payment and then your bank sends you some sort of notification because they're trying to, they did a bit of analysis based on the conditions and then block that payment. You get notified. We block these transactions because we felt this might be fraud, it's suspicious. Do you want to continue? Click yes or no at your own risk, and then you do that. But if your system could actually a little bit be context aware and then be able to adapt to that, be able to orchestrate different other agents who could share context. At the end of the day, when you think about microagents, you essentially still building microservices because ideally each of your agents should do one thing. And this is what microservices does. You have a specific service that carried out specific business rules, nothing more than that. And then they can actually communicate with others. But this time around, instead of just communicating with just request and response via HTTP, you have the context being shared with each of them and they understand. And it can even get better than that. I think that will be part of future recommendations to be able to find a way to persist some of this prompt so that it can actually be reused later on. And also quite transparent. And let's take a look at this problem. I think I mentioned it earlier, is you have an amount, you have this logic that says if someone is making transaction of an amount that is more than £1,000, and then this is the first time, that's just logic. Nothing's going to go. It's not going to make the payment. It's just entirely going to block that. Now, is this wrong? No, it's not, because that was the business rule. But what happens when someone needed to make these transactions and instead of you flagging it, you actually be able to reason about it, have your system think, get some sort of context around it. Who is this customer? What is the reason of making this transaction? Why do they need it? What time? Location? Specific carriers. All of those could come into play. And then it's not going to entirely bypass this, but it's going to go into this logic and then go into that conditional block and then do some other analysis. You could start thinking about confidence level. What does this look like? Of course, it's going to take a bit of experimenting with it because you're not going to get it right the first time. But this is the problem at the moment. Fixed rule. If it's more than 1,000, boom, reject. No context. All customers are the same. I don't care even if you are the prime minister, for as long as this is more than this, it's going to get flagged and blocked. And then the binary decision is, either 1 or 0. And this requires constant maintenance, which is what I mentioned earlier, is you have meetings. Okay, what can we do for customers who are from a different location? Should we adjust this logic So you have that back and forth, and we can make that better. So this is an example, a real-world example. You have a doctor who might actually want to purchase the medical equipment because it's, at that point, really urgent at 3 a.m. And for that amount, of course, your rule says if it's more than a specific amount, don't do that. But what if you could have your microservices think a little bit, understand that this doctor is from a specific hospital? I had a chat with someone recently about the same real-world example, and what the person told me is people could actually take advantage of this as well. If your system is actually bypassing based on this context, someone could be a fraudster and then channel money through maybe hospitals or something. And I know it's something that is quite obtainable, but at the end of the day, right, a little bit of experimenting, and over time, you get things right. But if your system could think about this, understand the context, and then take further steps. So I'm just going to show us a demo. Like I mentioned, this is really more like mock services. But at the end of the day, it just showed 3 different services, different scenarios. You have someone making a coffee purchase of £25 and electronics. And then the last one, you notice someone making more like a crypto exchange. This could be flagged as, this could be fraud, right? All the services will work the same way. Your traditional microservices will still get a request and response. The context might be different, but eventually you either block or just allow that transaction to go through. So I tried this a few minutes ago and it worked, so hopefully. So I tried to just make this a little bit interactive, so that's why I put just some timeout so that we can see that a little bit. So the first event is just £25, right? The coffee downtime, no problem. It goes through. The second one, it's getting a little bit of logging into that. What does this look like? Your traditional services will actually take a couple of actions. The fraud log, your fraud services can actually analyze that. And I do understand that most systems these days for your fraud microservice, there is a model behind it. Most of these models are built to identify patterns historically and then being able to share maybe confidence level. And based on that, you could allow those payments to go through. But still, the context more than that could actually still improve it. At the end of the day, payments being sent to payment provider and does that, and they get notifications. Like I said, most of these notifications are templated, right? All you have to do is pass email, name as the same generic notification for everyone. But based on this context, you could generate a personalized message for that customer. This is part of what Microagents could actually do. And then the £5,500 luxury electronics, the same rule applies, no context per se, just process the payment to confidence level. This could be more like coming from your machine learning model for fraud services. And then the same thing for the last transaction. It's crypto, right? This could raise a flag, specific amount. Do you still want to process this or you want to stop? So all of this works is transaction is blocked because of that amount. You get a call from your bank. Do you still want to proceed with this? Is this for real? Or are you getting yourself exposed to fraudsters? So this runs through all of this rule. You can see from this that there is no adaptive learning per se. It's all about the rules. It's all about the logic. If else, it goes through. And then the notification, nothing personalized about it. This is fine, right? But what happens if you take a look at the same logic that we showed earlier? You have amount, if it's more than 1,000 and it's first time. Now you go into that block and then try to analyze the transaction the merchant that person is, the time they're making the transactions, if they've got some sort of history. And then you could build on that, have different methods that could handle either this is medical emergency or not, or this is during business hours. So a whole lot of decisions have been made, even without that block, before you could actually go ahead and then return this pattern and maybe flag this as being suspicious or fraud. This is where the agent comes in. This goes beyond just ordinary IFS. When you think about it, nothing has changed from your initial logic. It's still, if it's more than 1,000 and it's the first time. But instead of blocking these customers immediately, you actually go ahead, make some decisions with your AI agent. So microagents in this context, I really want us to know that it's still more like your code backed by LLM or SLM, right? All you have to do is still pass a prompt to it based on the same event and then get some response back. Of course, this comes with a lot of challenges too. We'll get to that. But I'm sure people have questions around some of those challenges. And I mean, we've been playing around with ChatGPT for God knows when. And I'm very sure that's why I said everyone is an AI engineer, because prompting becomes part of our daily work. And now when you take a look at this architectural comparison, rather than just having an API gateway that sits in front of a microservices and do things like authentication, rate limiting, maybe you have a load balancers that then route to different services. It can still work like this, but then you can have more like a supervisor agent that orchestrates all of these other agents when needed. So it could be a request comes in, and then the supervisor agent picks up this request, and based on your prompts, you could pass events, pass some required data, and then say, send this request, look for the specific service that could handle this. And now each of those services could actually still pass context after understanding the history and the nature of that particular transaction. Now, all of this data can actually be persisted in the database somewhere and can be reused later. So essentially it becomes something that you're not losing the knowledge. It's not about just a logic alone. And for the communication agent, it becomes something that is personalized. Your notification service is always about template and payment aware. And also, it's still all about LLM, really. And for the second demo, just compare side to side with the first one. It's still the same, but what's different a little bit, if I can just clear that. So we have three agents, the fraud, the payments, and then communication. So, I mean, it depends on how you actually structure your code. You could have different agents being orchestrated based on the request coming in, and then those ones will be more like specialized agents based on the specific transactions that is about to be carried out on your platform. So the first one goes through, no issue. We could have the logs. Interesting. Right. Also, this is probably because my API key is not working, and so it just defaults to more like a default response there. But that's fine. But the message here is you have details about which of the agents are actually being used. Start with the supervisor who actually takes care of these transactions, and then check how many of these other agents could actually be orchestrated for this specific purpose. And maybe pay attention to the confidence level. Based on this, you could keep track of it for subsequent transactions and make changes. And then you have the same luxury electronics, same amounts, and the same thing with the last one where you have 15,000. Essentially, this is going to get blocked. But the point here is, instead of you just getting the transaction block without a specific personalized message, you're having specific reasons. This is blocked because of specific reason, and then this gives your customers some sort of idea of why it happened, rather than just this is our logic. If this is not met, then you have to stop the transaction. So this is all good, sounds all good theoretically. But do you want to go ahead and start changing your microservices, adding capability of AIs to it, turning them into microagents? So from what from my own experiment and from what I've seen from my research is try with one service, pick one, try to enhance that, add integration for decision support with LLM, and then over time, you're going to start getting a couple of confidence level based on specific transactions. You can identify transactions coming from a particular country at a specific time related to a specific business. It could be for health, it could be for e-commerce. And then you start processing some of this database. Now, when such transactions comes in, you will probably retrieve the same details, check the confidence level, and then it's going to get better over time. And then enable agent communication and eventually gradually expand. There's a lot of experimentation that will go on into this for you to actually be confident about completely having them work alongside your microservices. Some of the challenges is, these are more like LLM cost, sounds pretty obvious. Of course, the cost could actually add up. I don't know, probably because it's getting a lot of popularity now. You could have the cost being reduced a little bit, but it's still going to cost you for that. For the latency, it takes time to reason, and this is where the memory management comes in. Over time, you won't necessarily have to wait for an LLM to return the full response first, because you've actually had similar patterns persisted in the DB, and some of this confidence can improve how you undo other transactions. It can be unpredictable, right? You could get a different response from ChatGPT with the same question 7 times, right? Maybe change the wording or rephrase it in a different way. But these are also a way you can actually still experiment with it and over time build confidence on it. Of course, debugging is hard. This is similar to what is obtainable with distributed systems. You still need a little bit of observability. Why did this fail? When did it fail? Right? What country? Who is the user? All of those details goes into your traces and spans, and then you could check why all of those are happening. With that, you could help with debugging. So from some of the details is you don't want to throw this everywhere. If you have a simple CRUD application operations, the database will still work fine. Create, read, and write is simple. But when you have a part or a specific microservices that needs to deal with complex decision making, context-heavy processes, or entirely customer facing, you probably want to start thinking about adding microagent to supercharge them on a specific part. And over time, it's going to get some sort of improvement on that. So this is all I have. Thank you for listening. If you have questions, that would be great.
Any questions?
Yep, let's go.
Hiya. Very great session and very great idea, because I've seen cases where people are kind of stranded. Let's say for bank transactions, people need to urgently send something to their loved ones or just send some amount of money, and then it gets blocked and they have to go to the bank. And imagine it's a Sunday and the bank is closed and those other things. So this could actually solve the problem. The question I have is, how do you kind of supervise this agent? Because there are things that come up when there's kind of, should I say heavy use, or not heavy use, but when there's some sort of frequent use of artificial intelligence and some of these agents, things like algorithmic bias, where the information it has doesn't necessarily cover a particular set of people, or it doesn't really interpret that information well to cover certain demographics. So is there some sort of supervision or a way to check that, okay, how do we ensure that this agent, although it's supposed to be autonomous to a certain degree, how do we check these agents? How do we supervise them? How do we monitor them to be sure that they're actually giving the right input? So although they're supposed to be different inputs for different situations for different people, but how are we sure that at least they're giving something, the right thing, or something at least close enough to what we want, like our customers, like in a customer-facing applications now? So.
Yeah. Very good question. Especially for an environment where you have to handle payments, this is very sensitive and very important. And I think one of the strategies that I've actually found out is you being able to kind of deploy your own local LLM that actually actually backed your infrastructure. So rather than just a common open source one or run by a different company, because to some extent, some of those data are still exposed. And that won't stop it because it's still behind it. There's still some sort of models, handling all of those reasoning and giving you your powerful response back. Over time, this is where memory management comes in. Being able to save some of this prompt, because supercharging some of those new agents, it's all about the prompt. Identify the right agent who could handle this, who could handle specific part of a transaction. Now, persisting some of those details and identifying those patterns. So over time, when such a request comes in, rather than just retrieving something, it feels more like your caching system, right? Yeah, because you have data that are frequently being accessed. Now, all of this will goes into considering the confidence level. Do we still want to proceed with this kind of payment or not? And then you could identify patterns, track over time. And I think, to my understanding, I think it's going to get better. I think there's been a whole lot of improvements. There are a whole lot of early adopters. So many companies are experimenting with this. And then I think over time, we're going to start seeing adoptions from others. And that's why it's actually good that in an environment like this, people are actually getting exposed to it and then trying things out. That's what I feel.
This was the second guy here, and yeah.
Oh, sorry, guys. Hey, I think it's a very interesting concept of bringing intelligence to your services, right? I feel there's about 10 questions I want to ask you, but I'm going to go to, if you just go one slide back, there was like when you had the kind of good examples or grade 4 and not grade 4, right?
Yeah.
So right at the end.
This one?
No, right at the end, you had kind of like what are the good use cases and bad use cases?
Oh,
for this,
okay.
Right? One thing there surprised me a little bit, which was the regulatory compliance. Can you expand on that a little bit? Like, in what way is it good for or great for regulatory compliance?
So, for this aspect, you have I deal with details, different companies. There are different compliance. So some of those regulations can actually determine how you run your system and then how everything works together. So for this kind of use case, you probably want to leverage on the systems that can access probably different database, be able to collect data together, rather than you just sticking to a static data. So you could have something that can fetch data, retrieve, do some sort of analysis, and give response back to you. So this is where I feel, in a use case like that, regulatory compliance kind of fitting into it. That was my understanding of this particular use case. I don't know if that answers your question the right way.
I'm not sure I get it, if I'm honest, because to me it feels like regulatory compliance is one of the things where the uncertainty is the most difficult problem, right?
Yeah.
I feel most of the regulation I deal with, at least, is about consistency, above almost everything else, right? You need to be able to prove exactly where things came from, why decisions were made, all these things, right? And this is the common problem I feel I face, be it your personal use, be it your customers. Your customers don't like it when things are different every time they try them, and then especially regulation. So I don't know how to deal in my head with the uncertainty aspects, I guess, is the crux of my question, is how to deal with uncertainty where I feel it's such a huge problem for so many people.
Yeah. As much as this is part of a use case, I also think it's also a challenge because these are non-deterministic, right? So you get data back, and then this comes with part of being able to persist them over time, and then understand some of the data you're getting back, how the patterns work, and eventually, even if you have to discard any of those, because they're not really conforming to what the standard should be like, I think it's still part of the whole experimentation process, being able to get exposed to it, fail at it, and then get back and see if this is actually going to work or not.
Mm-hmm. Yeah.
Thank you.
Thank you.
My question is, how would you test such system before shipping it to production? It looks like there'll be such a high risk of having a lot of bugs in prod that will be producing intermittent errors, which is like nightmare to debug.
It is, and that's a good one. And I think the approach to this will be your deployment strategy, and then how you roll out products to customers. Ideally, a product like this, after being tested severally, would be to kind of feature flag it and leave it open to a subset of customers, that you can try with. And then depends on the experience of this customer over time, you could start expanding to other customers. And this, you more like leaving the feedback loop open so that you can get feedback from them and then see if you're getting better at it or not. This is why your traditional microservices is not going to go away, because if at some point this is not giving you the best result that you need, you could fall back on that. You could fall back on the traditional logic and then still maintain that, rather than just sticking to this as cast in stone. It's just going to be something you experiment with it, and if it works better, you can expand that. But start with a subset of customers, try with them, and then start expanding as you grow.
But before I'm reaching my customers, like with traditional software development lifecycle work here, like can I use agile or waterfall methodologies here?
I think anyone will work.
Yeah.
I think it depends on the team, really. Right. Most teams tend to adopt whatever works for them, and then getting result out of it will be like, oh, did this work for us? Let's experiment a little bit, or let's go agile straight, or just go the different one.
Yeah. Thank you.
Thank you for the talk. Actually, I have a question regarding technical capabilities of the experiment. So, did you try different LLMs, and what were the results? And again, did you notice any common drawback or any common challenge across these models that you tried? And if you've tried any form of guardrails to minimize any form of error?
To be honest, I think I've tried more with GPT 3.5 Turbo, and I do understand that there are others. I think I wanted to try a different one, but I've tried more with OpenAI, and I think that works fine. Of course, some of the drawbacks is what we talked about, hallucination, for example. You're getting tons of data back that you'll have to refine, and then based on this, you have to go back and refine your prompt as well. And this is where being able to persist some of your prompt works better. If at some point you're getting a reasonable response, you want to keep that prompt so that you can reuse it later on. And so those are some of those drawbacks. And then not being able to kind of pinpoint exactly what you want to get back, because you can't predict what the response will be. You could get a different response right now and get another one the next time. But I think understanding if this actually solves your business logic and then actually give you a right result back, irrespective of what the structure looks like. But if you're getting the right response, I think over time, you can keep using some of those records.
Okay. I do have another question, but you go ahead.
No, go for it. Why not?
Okay, so my question is in line with probably some form of a security violation, particularly prompt injection. So, for instance, now I can see that especially the agents is usually very interactive. So, is there any form of mechanism that you have in mind to prevent any form of a prompt injection that can lead to any security violations?
So these are something that you'll have to define yourself, right? So this, did you talk about interactive because of the terminal?
Yeah.
Oh, that was intentional actually.
Okay.
Because if I run that, you're just going to see everything run all at once. But I wanted to be able to pass the message across by processing each of the payment one after the other. But ideally what you will get is you have a payment transactions coming in as a request. And then you handle that with your handler, and then you get a response back. So it's going to run through all of those without needing to stop making decisions in between. You're not going to see something like that. So it's just going to run everything through, give you a response that then you cannot reuse.
Okay, fine. Thank you.
We have real software engineers, so it's maybe
That's
a totally
fine.
naive question, but I was interested by your idea that one of your agents could be the communication one, right? The one that rather than just giving a template,
Exactly.
fills in a message. It's my understanding that if there's a fraudulent transaction, then having the template be exactly the same is actually a very desirable feature because it doesn't tell the people doing the scam anything about how to change it. And so it strikes me it might be a terrible idea to put the reason that a transaction has been flagged in the message, because if the message is actually controlled by the scammers, then that just tells them what to change next time. Is there scope to have a sort of maybe even one extra agent that tries to figure out if it's appropriate to put this extra information in if the reason for it being blocked is some simple thing like they filled in the name field wrong, or the date on the credit card or whatever, something that's unlikely to be fraud, but keep things as opaque as possible, and not return that extra information if they think it is, a case of genuine fraud and the thing being controlled by some bad actor.
Yeah.
Makes sense?
That's actually a very good idea because essentially you will have different agents that you need to orchestrate and then be able to exchange context between each of them. And a process like this could be instead of you returning all the response back, have another agent to kind of see that again and then readjust. The essence of a system like RAG is being able to refine your response and then refine it all over again so that you can get a different ones that makes a lot of sense. I would imagine that our customers who's actually been exposed to fraud will actually mean maybe they send them a link or something like that, and the customers should actually be the one getting the response rather than the fraudster that sends those links. So, but you made a very important point there, being able to come up with a different agent that could still supervise all of those before you eventually get the response out.
So thank you for the talk.
Thank you.
And I think their use cases and regulatory complaints probably placed a bit wrong because, as far as I know, their finance industry is very heavily regulated. And right now, all the models must be explainable and predictable. So right now, it is not possible to use LLM agent until it becomes explainable and predictable. So could you address these things?
That's a very good point. When you asked the question earlier, it actually raises that very good point of, do you want to stick with something that is non-deterministic for something like regulatory compliance? And this is the point of still being able to experiment comes in. And then you've just kind of buttressed the same point too. So this is something that will require going back and refining and rethinking. Do you want to apply such agents to a regulatory compliance system or not?
Yeah, and one more. Probably this talk could give a bit of gray hairs to legal department. But for example, if someone manages to make a prompt, for example, for Sam Altman with 1,000 pounds for new iPhone, and it will pass. And then someone else with their name Mohammed Suleiman made the same transaction for the same iPhone, and it will not pass. And the difference in the prompt will be only in the name, and it could get public. Well, how to... my question is how to get rid of the inherent biases of the LLM agents, and how to be not only compliant with their regulations, but also be safe in terms of legal issues.
Yeah. So when you think about it, you're still in charge of the prompt, not the customers, not the users. So this is where we talked about you being able to experiment over time. You want to structure the context to what do you want to flag based on the customer's persona. Is it the time of that transaction, the country, the name, and every other factor that could come into play? Now, based on this, you could start refining and persisting them over time. And the next time such transaction is going to come in, you want to check your confidence level. This is not just something that's going to be infused and then solve a lot of problem immediately. To be honest, it's going to take time to experiment with it, build with it, and then confirm if this is something that you feel will actually work based on the confidence level you're getting back, and then eventually carrying out that particular transaction. For any rigid system, it's just as simple as if this is this amount and this country, don't process the transaction, right? There are cases when you will have to provide reasons why you want to send money to a specific country or why you want to carry particular transactions, which is where your bank will have to come in and block that transaction. It's still their system, right? They're trying to make you safe, prevent you from fraud. But if you bring in a system that actually understands the context a little bit into it, to some extent, you could, by the time you experiment with that, you could get feedback and say, if this has been consistently right for a number of time, then this might be something we want to start exposing to a couple of customers a little bit, and then start readjusting, work on the biases. We talked about you being able to manage your local LLM within your infrastructures rather than just going for some of the public models that would have to power that. So those are more like ideas that I feel could actually help with it.
Yeah. Thanks for the answer. But my question was not about their the accuracy of the model, but also about their biases, because whenever you judge someone by his name or his gender or skin color, well, it could be it could be a right correlation, but you cannot make this decision based on their skin color.
Yeah, I understand you. So this is where, being able to have your infrastructures could come in. Maybe you could refine your model to actually at least be less biased in that regard. But I still think this will require a whole lot of usage, constantly, and then being able to analyze if this is something that you eventually want to adopt or not.
Yeah.
Does that make sense?
Yeah.
Cool.
Actually, I have a question. Which will probably answer that a little bit and maybe ask one more question. Have you tried to run your local some open source LLMs? If yes, which is easier to run, maybe which is easier to orchestrate, and can it be a solution to the problems like that when you just customize it to your needs?
So for now, I've not actually been able to run that. I think what I've actually played around with is more like an MCP. But eventually, some of these are still powered by some of these, the open source. And other than that, try out some of those models. But I feel like if you have the capability to be able to train your own model, set up your own LLM. You'll be in charge of being able to refine how it reacts to like some of those transactions, and then how biased it can be to identify customers and their transactions and the kind of response it needs to give back to them.
Okay.
So I guess I got a follow-up question. I'm a researcher. So I guess my question is, I would be someone who manage your internal database or analyze your internal data. Where do you think a researcher could come in? Would we be the person who, the people who support with the prompt engineering, or would we be the people who actually help you define the list of contextual influences?
Great question. I think at that point, you've just answered it. To my understanding, is part of being able to understand what a prompt looks like, being able to identify the patterns, right? Some of the data that are actually coming in, the personas of the customers, right? How often do we get such requests from this location or from this, within this particular time? Understands all of those details and then be able to adjust if you're making progress or not with your product. Researchers sitting in between analyzing historical data and then suggesting a better way for you to kind of improve how you use data for customers. So I would say in between prompt and then also understanding the personas of customers and suggesting how to better structure prompt, for example, for customers.
Thank you so much for the talk. I have a non-technical question. I came here to hear out your engineering perspective, how you approach architecting, and I hear fantastic customer-centric mindset that you have. I'm curious because I consult companies in customer experience and user experience, and I'm curious, is it your kind of personal thing, or do you believe that engineers should all be like that and be responsible for creating good customer experience as well? And how can, because I work directly with founders mostly, and how, so for my understanding, how I can, stimulate this kind of customer centricity in the engineering teams would a screenshot of persona on their desktop be enough, or should there be more translation of this user experience artifacts like persona to more technical requirements? Does it make sense?
Yeah. I don't think there will be engineers without customers to begin with, because essentially what you're doing is you're solving problems for customers.
Yeah.
And sometimes as engineers, we happen to be customers to other engineers, right? And, we use tools from different companies to kind of improve our development. So you have developer experience. At that point, even engineers become customers too as well. So it's all about solving problem. To be honest, this was one of the reasons why I actually started engineering in the first place, because, being able to identify a problem of a customer and solving that problem, you are paid based on the values you can offer to someone. So if you're solving their problem, they're going to pay you. So I feel like not just the aesthetics, not just about your fantastic ideas and logics. Would this solve a problem of someone? Would they be able to come back and use your tool or your platform or whatever you're building? And if they can do that, then you have someone's problem solved, and then you can retain them and they can keep coming back. So I feel like the message is engineers should see as solving problems. And then if there are no one to actually have those solutions to give out to, then you're essentially just building in silos. So it's all about the customer first. And then whatever you build, that's where the feedback loop is very important. Your customers use your product and they give you feedback. and over time you refine your logic a little bit. All of this kind of idea we're talking about to refine your microservices, to supercharge them, make them think differently, is still all about the customers. So it's all about improving the experience. I've always been like that, and I think that's where most engineers that I've worked with are.
Okay, thank you. Do you think there's a way to kind of stimulate to I don't know, to grow empathy in engineers?
I think it's all about mindset, and people tend to change over time when they understand that the problem they're solving is not for themselves alone. It's actually for a couple of people. Even without software engineering, engineering generally is just problem solving. So being able to pass that message across and have some sort of mindset shifting, whichever way you can pass the message, let them know that this is all about solving problem for people. It's not just about yourself. And once engineers start thinking that way, they're just going to start building products that will affect customers' life positively.
Thank you.
Just to add to what he said, so there are many ways to look at this. I'm more of a front-end engineer, so I deal mostly with the parts that customers interact with, what they see on the screen. And I feel like, so to me, I look at it that there are two parts to a software: what the customer sees and interacts with, the feedback they get from it, and the things that they don't necessarily see. There are a lot of decisions that we'll make as engineers, maybe to make the software better, to make it go faster, to make the code cleaner, to make the architecture better, that the customers might not see, but it might overall improve their experience of using the platform. Sometimes it's easy to get caught up in the very technical aspects and forget about how the customers are. Sometimes you might not really even see the effect of this till you ship a product to production and you start dealing with customer tickets. Then you know that, oh, this feature was better, this feature was not so good, these are things to change. And I feel like it's easier in startups to actually think of the customer first, because that's a smaller team. A lot of business decisions are being made that you're aware of. So you're not just building products, you're aware why this feature is being built. You're not just building features. Sometimes the problem comes in bigger corporations or bigger organizations where the higher ups would have made the decision, spoken about the business processes and why, and then maybe the engineers in a certain team are just given the task to fulfill. So to them, they just want to fulfill the task. They might not always understand the yes. So sometimes it falls on us personally to know why we're doing this. We want to solve problems. If I'm writing a piece of code, it's also nice to know why and how this fits into the system as a whole and how it helps the customer. And sometimes it also falls on some of the bigger corporations to kind of pass certain information to the engineers. So it's not just, I'm giving you this task to do, move your Jira ticket, and that's it. It's like, this is why we're building this feature. So different teams have different heads, maybe head of software engineering, head of front end. So those things should be kind of passed down so that when we're making certain decisions, we know how we actually affect the customers. Because sometimes while some things can be really important, we can put a lot of energy into building a lot of things that the customer might not even use or care about. And that is actually something that is like a conscious and constant effort that we have to be looking out for.
And you can achieve that by working with researchers. Thank you, it's very helpful.
Are we allowed to make counter opinions?